Okay guys, this is Unit 4.4 video. The objective for this video is for you to take a graph of either sine or cosine and write an equation for it either in sine or in cosine. For this particular example, I notice that my graph goes through the origin. If my graph was to start from the minimum or the maximum, then I would instead use cosine. So I'll put a little note here. Second, I'm going to look vertically. Vertically, the y values go from -2 to 2. That tells me that my amplitude has a value of 2 units. So A is going to be a 2. I don't know if it's positive or negative yet. I didn't think about that. I noticed that from the origin, though, the graph goes from 0, 0, 0 to its minimum. In the last video, we learned that when the graph goes from the origin to a min first, that means that the a value has to be negative. For a d value, the d value means that the graph was shifted up or down. Because the graph starts at the origin and the y values are the same, -2 and 2, this tells me that my d value is 0. For the period, let me trace over one complete period for this function. And it looks like when it completes one full cycle, the x value starts at 0 and it ends at pi. This tells me that my period value is going to be pi units. I want to know what the value of b is. So in order to do that, I'm going to do 2 pi, which is what I did in the last video, and I'm going to divide it by b. In the last video, we had the luxury of knowing what the b value was. Here, I'm trying to solve for b, and when I do 2 pi divided by the b value, I should get a pi out. Now, when I solve for b, actually, I do get a b value of 2. Hopefully you can see that looking at the origin, because sine usually starts at the origin. So now I'm going to combine all my information down here. I'm going to have y is equal to, and because I'm using the sine function, I'm going to have y equal to -2 times sine, and then the b value is 2x, and that's it. I would strongly encourage you to check your answers on a graphing calculator or on Desmos.com, particularly when you're doing your own work. In example 2, you're going to be required to write 2 equations this time, one in terms of sine and one in terms of cosine, because you're able to do that. Take a look at my reminder here. The red function is a graph of cosine. The green function is the graph of sine. And I'm telling you that cosine x is equal to sine of x plus pi over 2. Here's how I got that. And we're going to want to remember this. The sine function is what I actually wanted, because I know that cosine and sine both look like the same graph. It's just a matter of moving one to the left or to the right. If I want to start with the sine function and turn it into the cosine function, I have to move the graph of sine, pi over 2 units, to the left. So let me just write this down. So again, if I wanted to take my sine function, which is in green, and then stop at my cosine function, I have to move pi over 2 units to the left. So these two will be equivalent. Take a look at this example. And again, I know this isn't in your package, so please add it somewhere in there. Tell me what cosine is going to be, what sine is going to be equal to in terms of cosine then. You're given that the green graph is cosine, and I want to end at my red graph, which is sine. Please pause the video now to answer this question. Okay, so if I want to go from cosine to sine, remember that's going to happen at when sine is pi over 2, which means I need to go to the right pi over 2 units. when I'm going to the right, what I should fill in here is going to be an x minus pi over 2. So a sine function is always equal to cosine when the cosine graph is shifted pi over 2 units to the right. You'll want to box that in because that will come up later on too. And the cosine function will equal sine when the sine function is moved to the left pi over 2 units. So with that said, let's go back to the example that we were actually looking at. Please pause the video now to try to write two equations of this graph. Okay, I'm assuming that you have already tried the problem. The first thing that I'm looking at is I see that this graph starts at its minimum. That tells me that the function is going to be cosine. If the graph started at the origin, that means I'm going to be looking at a sine graph. Second, I'm going to look at the vertical range. The range of this graph is from -1 to 5. Finding the distance between those is equal to 6. But that's twice the amplitude, so let me cut that in half, and I get a value of 3. So what that tells me is my original range was from -3 to 3. That's what this graph was supposed to be. In order to get the range from -1 to 5, I need to move -3 up and 3 up 2 units. Because I'm moving the graph up 2 units, d is equal to a positive 2. Now, is a going to be a positive 3 or a negative 3? Again, my cosine graph is starting out at its minimum. That means a has to be a negative value. So a is equal to -3. The period. The period was from negative pi to pi. The distance between those is 2 pi. To solve for b, you should have done 2 pi divided by b, and that gets a b value equal to 1. There was no horizontal shift, so now I can write my first equation. My first equation is going to be y is equal to -3 cosine of 1x plus 2. Now the other part, I need to write an equation for sine. So my second equation is y equals -3 sine, and I'm moving my graph to the left pi over 2 units, so it's going to be x plus pi over 2 plus 2. This is our final answer. Example 3 we'll do together, and then example 4 I'll ask you to pause the video. For this function, I don't really know if -1 is where the midline for this function is. I also don't know if this x-intercept is where the midline is. It looks like the x-axis cuts this graph in half, but again, I'm not really sure. So what I'm going to do is I'm going to start with the min. The min tells me that I'm going to start with cosine. Now looking vertically, I had a -2 value and I went up to 4. So to find the distance between those, I'm doing 4 minus -2 is 6. That's 2 times the amplitude, so let's cut that in half, and that gets us a 3. That means that my actual amplitude was from, my actual range was from -3 to 3. But I was supposed to get to -2 to 4 though. So I had to go up 1 unit, and because I'm going up 1 unit, that means my d value is a positive 1. Now, for the a value is going to be a positive or -3. It's going to be a -3 here because I am starting with my minimum. For the period, I started at -0.75, and I'm going to end up at 1.75. 1.25 rather. So let me find the distance between those two because that will tell me the length of my period. So my period is 2 full units. My job though is to solve for b, so I'm going to do 2 pi divided by b is equal to 2 units. That's going to tell me that b must be equal to pi. All I need is my c over b value. At the beginning, I told you that this cosine function looks like it was shifted to the right some units. it was shifted to the right 0.25. Another way to say 0.25 is 1 over 4. So this graph was shifted to the right 1/4. So my C over B value, when I go to the right, that's going to be a negative 1 over 4. And now I can combine all the information that I have to write my first equation. The second equation, I want to be careful here. I'm going to do one extra step. My second equation, I'm going to do y is equal to negative 3 cosine of pi x minus pi over 4 plus 1. If you're going to write a second equation, and you need to write your second equation in terms of sine, we got to be careful. The a won't change. So I'm going to have negative 3 sine of something. The period won't change. So we'll put the pi x. The minus pi over 4 won't change. So we'll put that there. So if I'm going to go to the left, pi over 2 units, that means I'm going to have a positive pi over 2 here. It's going to be up to your teacher whether or not they actually want you to simplify. My class, I'll tell you what I expect when I see you in class the next day. This was your first equation, and this is your second equation in terms of sine and cosine. This one, the middle equation, was used, so I can write the sine equation clearly. Here's example 4. Please pause the video to try this on your own. Resume once you think you have the answer. Okay, it looks like this graph is supposed to be a sine function. It looks like this midline is supposed to be at y equals negative 1. But again, I'm not really that sure of it. So what I'm going to do is I'm just going to start at the minimum again. If I'm starting with my min, that means I'm going to cosine right away. Finding the distance between negative 1 and 3, you get 4. 4 divided by 2 is 2. So my original range was from negative 2 to 2, but I had to shift the graph down 1 unit to get to the desired range of negative 3 to 1. This side note tells me that d is equal to a negative 1. If my answer is different than yours at the end, please make sure again you verified your answer on a graphing utility, please. D is equal to negative 1. That's going to be my my vertical shift. My amplitude I saw was going to be a 2. So A is going to be equal to 2 for sure. My job is to determine if it's a positive or negative 2. Because this value starts at a minimum, I'm going to use a negative 2. I want to emphasize there are multiple answers, so please do not erase your work if your answer is different than mine. The period, I started at negative 3 pi over 4, and in one cycle I got to pi over 4. The distance is going to be equal to pi. So the total length of the cycle is pi units long. My job is to solve for b, which means b has to be equal to 2. My horizontal shift, I move my graph to the left pi over 4 units. Because I moved the graph left pi over 4 units, my c over b value is going to be equal to a positive pi over 4. My first equation using cosine. To write the second equation, I am going to take the time to distribute this 2. And then just like in the last video, if I want to go from cosine to sine, my second equation is going to be y is equal to negative 2 sine 2x. And again, I am shifting the graph of sine to the left pi over 2 units. So it's going to be the same plus pi over 2, and then another plus pi over 2 minus 1. And this one is actually pretty easy to clean up, so we'll do y is equal to negative 2 sine of 2x plus pi minus 1, and that should give me the same answer. Again, you might have a different answer, but please, please, please check your answer on the graphing calculator, and when in doubt, please see your respective teacher or go to the MRC. Other than that, thanks for watching the video, guys.